So here I want to solve this system of equations. 4x plus 2y is equal to 6 and 3x plus y is equal to 9. I'm going to choose either one of these two equations and I'm going to solve it for one of my variables. So in this case I'm going to choose my second equation just because we have a y that's already isolated in the equation, so it would be a lot easier to solve for y than it would be to solve for either variable in the first equation. So I just rewrote the second equation here in orange, and in order to solve this equation for y, and you could solve it for x if you wanted to, well, you could solve it for x if you wanted to. It would take a couple more steps, but if I wanted to solve for y, in order to isolate my y, I see that my y is being added to 3x, so I'm going to subtract 3x from both sides of my equation, and I have to subtract that whole term, so that is a 0 pair, so that no longer adds value, and then we end up with, bring down our y is equal to 9 minus 3x. Remember, 9 and negative 3x are not like terms, so you can't combine them, so you just write them like this. So now we have that y is equal to 9 minus 3x, so now we're going to take our value for y and substitute it into our first equation for y. So I'm going to rewrite my first equation, 4x plus 2, and it's 2y, but instead of y, I'm going to put what y equals in parentheses. And that is equal to 6. Right? So we rewrote our first equation, but instead of y, we wrote 9 minus 3x, and we rewrote our equation with that information. The next step here is to distribute. So now you want to distribute, use your distributive property to distribute that 2 on the outside of parentheses to everything inside parentheses. So once we do that, we'll still have our 4x here, plus, we'll do 2 times 9, which is 18, minus 2 times 3x, which is 6x, and all of that is still equal to 6. Now, the third step would be to combine like terms. So I see, oops, this does not work. I see an x term here, an x term here. Remember, you got to keep the sign that is in front, right? There's like an invisible plus. So I see a plus 4x minus 6x. So that will combine to be negative 2x. Right? Then we have our constant 18. And all of that is still equal to 6. So now we can solve for x. So here, we want to use algebra. There's lots of different ways you can approach this. I'm going to just do it the normal algebraic way. I'm going to subtract 18 from both sides. 6 minus 18, is that negative 12? I think that's negative 12. Yes. Is equal to 2x. And I'm going to divide both sides by 2. That creates a 1 pair. So x is equal to negative 6. So we know one of our variables. So at this point, after we've done all this work, we know that x is equal to negative 6. Now the last step for this is you want to take the variable that you've solved for and substitute it into either one of your equations to find y. So I'm going to just extend this. We know that x is equal to 6. So I'm going to substitute that one into, I'm going to substitute it into my second equation. No real reason. I think it just looks a little bit easier. So let's substitute negative 6 in for x into our second equation to solve for y. So our second equation was 3x. So 3, instead of x, we're going to put negative 6 in parentheses, plus y equals 9. So 3 times negative 6, 6, 12, 18 is negative 18, plus y equals 9. And then we're going to solve for y. So you can say negative 18 plus what equals 9, or you can just go ahead and add 18 to both sides, and you will end up with y is equal to, I think, 27? 27, almost positive. So now you have x is equal to -6, y is equal to 27. So our final answer, let me pick a different color. Our final answer should be that the solution to the systems of equations is the point -6, +27. You can check your work graphing, or you can substitute x and y into both of your original equations and see that they both make true statements. So, final answer in a box. Always check your work via graphing or substitution.